What's up, guys and girls? Welcome to AP Statistics. In this video, we're going to talk about analyzing categorical data. Previous video was over organizing categorical data. Well, we're not just organizing anymore. We're actually going to talk and analyze what it is we see. So the organization has been done. Now we're ready to do some analysis of our data. All right, so let's talk about describing/analyzing a single categorical variable. So there really isn't a whole lot to say when analyzing a single categorical variable. We simply discuss the distribution of the responses amongst the outcomes. We often like to report the most common outcome and maybe the least common outcome. So we're just trying to talk about what outcomes were there, what were most likely, least likely, and so forth like that. Now, you can report the total counts for each outcomes, but it tends to actually make more sense to report the proportions of each outcomes since they are relative to the whole. Now, a lot of kids say relative to the whole. What does that mean? Well, think about this. If we looked at our data of, hey, what streaming services do you subscribe to? And we reported, wow, 89 people subscribe to Disney Plus. People might wonder, is 89 a lot or a little? Like just knowing 89 people subscribe to Disney Plus, I mean, that number itself doesn't really make a lot of sense. Whereas using the proportion of subscribers makes a whole lot more sense, and it's easier for the reader to understand that data. So again, when we talk about being relative to the whole, we just mean dividing that count by the whole total amount of people that responded. So again, if we had 100 people and 89 purchased Disney Plus, we'd be like, oh my gosh, wow, 89%, that's a large proportion of people that have Disney Plus. But if we had 750 total people and 89 purchased Disney Plus, that would only be 11.9%, which is really not nearly as high. So just saying 89 alone doesn't really convey enough to the reader, whereas a proportion conveys a lot more to the reader because it's saying, hey, relative to the whole, here's the proportion that purchased Disney Plus. And for most people, that makes a lot more sense. They notice say, oh yeah, 89% is a lot bigger than 11.9%. Whereas if you just give the number 89 in terms of a count, you're not really sure if that's a large count or a small count, whereas proportions kind of tell you that. So here is an example on the next slide that we're going to take a look at of a really simple analysis of a single categorical variable. So here is a single categorical variable. What streaming services do you purchase as of right now? Here is all of the frequencies, here are all of the counts, and then I also turned it into the percentages or the relative proportion because as we talked about, oftentimes that's a little bit better to convey to your readers. So when we give this description, there's not a ton to say, but we definitely want to make sure that what we do say is full of context. Now, context means don't say it is this, they have this, right? You don't want to use pronouns that aren't defined. You don't want to be blah. You want to talk in context. So you want to make sure that you're talking about the who, what, the where, when, the why. You want to give it all, right? So here is my pretty good description of this data. A large group of people across the U.S. were randomly surveyed. So there's my who. Want to inform the reader who I'm talking about. And they were asked which streaming services they currently pay for. There's my what. What are we talking about? Data found that Netflix is the most common with 22.8% of those surveyed using it. So again, I want to mention the most commonly used. And notice that I underlined of those surveyed. You do not, this is just a sample, right? The last thing we want to say is 22.8% of all people use Netflix because we certainly don't know that to be guaranteed to be true. And then I also mentioned a couple of the other high ones. I thought that was worth noting. Hulu at 18.5%, Amazon Prime at 13.2%, Disney Plus at 10.5%, and HBO Max at 10.6% are some of the other most common streaming services used by, again, those in the survey. Then I also thought it'd be worth mentioning some of the lower ones. Some of the newer streaming services like Peacock and Discovery Plus at 2.1 and 1.7% were the least used by those in the survey. So did I mention every single outcome? Well, no, there was quite a few. If there's only 4 outcomes, yeah, mention all of them. But with a lot of outcomes, I thought it was super important to mention the most common, some of the other ones that are fairly higher, and also mention the two lower ones that I saw. Now, the ultimate goal with any single categorical variable is to really generalize your findings to the greater population from which the data came. Remember, we talked about this extensively in class. We're always searching for that parameter. A parameter is a value that comes from a population. And it's really hard to find that value without doing a census. But we can take a sample which produces a statistic. And our goal is to hope that that statistic, that value from the sample, is really dang close to the population. And as long as, it's the two R's, as long as your sample was randomly selected and representative of that population, which means it shouldn't have any bias, then we can generalize our findings to that larger population. So here's an example of me actually doing that in relation to the previous problem. Our sample showed 22.8% of people subscribed to Netflix. Since that sample was random and it was representative, at least I was told it was, I could infer that roughly 23% of all people across the US subscribe to Netflix. Do I know that to be a guaranteed fact? No. That's why I threw the word roughly in there. That's why I actually rounded it to 23%, because I'm still not sure it's a guaranteed, but because it was random and representative, it should be very close to that population parameter, so I could generalize that to being something that I would imagine is probably pretty close to what's true for all people across the US. One of the most important things you do here is, because there is so little to say, make sure you write in full, complete sentences. Explain the who, explain the what, the where. Where did the population come from? Where did your sample come from? When was it done? Is this current? Is this old? And why? Why are we looking at this? Now, do you have to mention every teeny tiny thing? No, but again, talk in context. Make sure that you're not just saying Hulu was this, Netflix was that, the other ones were this. Like, you don't want to be blah like a robot. You want to add a little character to it, add that context, make sure people know where your data came from, how big that sample size was, who was involved, why you're doing this, what it is you're looking at. All of that can make something that where you don't have a whole lot to say, gives you a whole lot to say. All right, now let's talk about describing the relationship between two categorical variables. This will give us a lot more to say. This is far more interesting. Now, the moment we look at two categorical variables together in like a two-way table, we instantly have two things. One, we have what's called the marginal distribution for each variable. These are looking at one variable at a time and looking at the frequencies or relative frequencies of all of those respondents, out of all the respondents. So again, a marginal distribution is saying, okay, I know that I have two things in this table. I know it's a two-way table, but I'm only going to look at one variable. And that's my marginal distribution. Or then I say, okay, let me look at the other variable, just that other variable. That's a marginal distribution. And of course, we're going to look at an example of this in a minute. The second thing is conditional distributions. These are the numbers within the table. The conditional distribution of one variable's outcome across the other variable. Here we are looking at the relationship that one variable has on the other. Much more, I don't want to say complicated, but it's a little bit more involved, and we're going to look at some examples to understand this. But before we actually look at a two-way table, I want to make sure you understand how the wording of a marginal versus a conditional distribution happens. Okay, so here is an example where we're looking at gender, female, male, and the preference of candy. I don't know, a whole lot of different candies, gummy candy, chocolate candy, fruity candies, this candy, whatever. Okay, just candy. And here's a marginal example. So if we forget about gender for a second, let's just look at candy. 35% of all people surveyed said they love chocolate candy. That is a marginal distribution. It's only caring about one particular variable, candy, and we're looking at the chocolate. So another example would be, and also 56% of all people surveyed love fruity candy. Again, those two questions are marginal because they only involve a single variable. What type of candy is it that you like? And it was measured from all of those surveyed. Where conditional distributions, we're now combining the two variables. So here we're saying, okay, of the men. So now we're looking at gender, and we're only looking at men, by the way. We're only looking at of the men. So of all the men. So that actually changes my denominator, right? When you find a proportion, you divide. And now this is changing my denominator. So my denominator is only the men. So of the men, I found 21% love chocolate candy. Of the men, again, changing my denominator, 78% love fruity candy. All right, so let's make sure we understand the difference that's going on here. This is really important. When I mentioned that 35% of all surveyed love chocolate candy, that means I was finding the proportion of those that like chocolate over all people. So whether you're male, female, didn't matter. I was dividing by everybody, but I was specifically looking at chocolate, and again, I got 35%. But now down here, conditionally, I said, well, hold on a second. I only want to look at the men. So now the condition says you're only allowed to divide by the men. You're only looking at the total men. Now, we're still looking at chocolate, but we're only looking at chocolate amongst the men. So we're really conditioning ourselves there. And we found out that 21% of men like chocolate. And then again, I also did fruity, 78% of men like fruity candy. And then we could also look at women, right? So of the women, okay, so now my denominator changes. It's only the women. So of the women, what percent like chocolate? And again, we found out 48% of the women like chocolate. So notice the changing of the wording, right? Now I don't have to use the word of. I could say like amongst the men. It's another way of saying it. If you are a man, right? It's another way of conditioning just to looking at men. And you know what? Something else I don't even have written here is I could flip all this around and look at those that like chocolate. So if I said, of the people who like chocolates. Now my denominator is the chocolate lovers. Of all the people who love chocolate, what proportion are men? So that's, again, it's a whole different way of looking at it. That's not going to be 21%, right? It's a different way of looking at it, right? So I'm not looking at the men, I'm looking at the chocolate lovers, some of which could be men or women. So again, that's where we get into conditional, when we find ways to incorporate two different variables in the same sentence, I guess. And it's really important that you get the denominator correct. The denominator is who you're looking at. That's the amongst or the of or the if. Okay, hopefully that makes sense. And as we look at a table here, now this should make a lot of sense. So here is some data that we saw in the previous video, but this data was collected looking at age of respondents in terms of a category: teenager, young adult, middle-aged adult, and elderly, and looking at what is their favorite social media app that they use: Facebook, Instagram, Snapchat, TikTok, or Twitter. So again, the marginal distributions are in the totals. So if a marginal distribution would say, forget about social media for a second, let's only look at teenagers. 280 teenagers, 304 young adult, 176 middle-aged, 115 elderly. Again, we're only looking at that one variable, age. And then again, a second marginal distribution would be, okay, now let's focus only on social media. Social media, 174 Facebook, 200 Instagram, 160 Snapchat, 168 TikTok, 173 Twitter. Now, of course, any total could be made into a proportion as well. So if I said, what proportion use Facebook? Now I'm going to take the 174, I'm going to divide it by the 875. That would be the proportion of people who use Facebook. Or if I said, what proportion are young adults? That's 304 divided by 875. Again, marginal, you're taking it and you're dividing it by the total, all people, when you're thinking about marginal distributions. Now, conditional distributions are the numbers within the charts. This is where we start to combine these two ideas of age and social media preference together. So in red here, this specific row, this one row is saying of the teenagers. Of the teenagers. So this red is circling only the teenagers. So now we're saying, hey, we only want to look at the 280 teenagers, 10 of which like Facebook. So this is conditional. This is of the teenagers, what proportion like Facebook? 52 out of 280 of the teenagers, what proportion like Instagram? 117 out of 280 of the teenagers, what proportion love TikTok? Again, conditionally, we're only looking at that row of teenagers. And I could do the same thing for the row of young adult, middle-aged adult, or elderly. Or I could go vertically and look at the column. So here in blue, I'm looking at the column of Twitter. So this is only looking at those that use Twitter. So of the 173 people that use Twitter, 38 are teenagers. So this is the proportion of teenagers of those who love Twitter. Or if we looked at 68 out of 173, we're saying amongst the people who love Twitter, what proportion are young adults? That would be 68 young adults out of the 173 that are the Twitter lovers, whatever, okay? So again, conditional, you got to be really careful. You could go vertically or horizontally, and then you can say, okay, who am I looking at? What group am I conditioned to? Am I only conditioned to the teenagers in that teenage row? Am I only conditioned to the Twitter lovers in that Twitter column? You get the idea. Okay, now before we talk a little bit more about analyzing this, we got to talk about notation. So, we do have a mathematical notation when we talk about these marginal and conditional proportions. And I want to introduce this notation to you because we're going to use it a lot this year. So when you're examining the proportions, we have a shorthand notation here. This is just shorthand notation. This is for quick reference and for quick understanding. This is not to be used in a formal written paragraph of an analysis. So just note that, okay? This is just quick reference. So it's very simple. So we use the capital letter P for proportion. That's what it stands for. It could also stand for percentage, right? Because a portion can easily be turned into a percentage. And then in parentheses, we simply say what it is we're looking for. So this is the marginal thing. This is the outcome, the one and only one outcome that we are looking for. And then, of course, we actually find that proportion, which we could also change to a percentage. So here are some really simple examples. Hey, what proportion of all the people in your survey love chocolate? This is just shorthand notation for that. P for proportion or percentage. And in parentheses, you could even shortcut what it means you're looking for. So chocolate, I could even abbreviate chocolate, C-O-C-H-O-C. And then again, so now I'm saying, okay, how many people like chocolate divided by all the people in my survey, marginal, divided by everybody, and I got 35%. Here's another one. This is actually from our data on teenagers. So we said, okay, what proportion of all people are teenagers? Again, this is just a marginal, single, one thing at a time. So I said, well, again, go back to our data real quick. There are 280 total teenagers divided by 875. So again, that's actually how I got that number. 280 divided by 875, I got the 48%. So 48% of people in my survey were teenagers. What proportion of people love Facebook? Again, I'm not mentioning anything else. Marginals, one thing at a time. So again, Facebook, 174 total people love using Facebook. Divide that by 875, and that's how I got the number 0.199 or 19.9%. Okay? I typically like to keep 3 decimals. And then when I move the decimal, that could actually, as a percentage, that would be 1 decimal place. But you get the idea. So I think the 35 and the 48 were pretty exact there. But typically I like to go 3 decimals. All right, now if we're going to notate conditional proportions, now remember, now we're incorporating 2 things. This is huge. Just really pay attention here. Once again, P for proportion, P for percentage. Now in here we have a bar. We have this vertical bar. On the right side or the back goes the of. This is who we're looking at, okay? This is the of or the amongst. All right, I call it the condition. This is the condition. This is the group our attention is focused on. And then in the front is, again, what we're looking for, okay? And then again, you find your answer. But again, so we're actually incorporating 2 things. Remember, conditional, 2 variables now we're incorporating. So in the back goes the condition or the of or the amongst. In the front goes what you're looking for. So here I'm looking for the proportion of men that love chocolate. So of men, meaning I'm conditioned. The condition is I'm only allowed to look at men. That goes in the back. And then it doesn't change. I'm looking for chocolate. The ultimate goal is to find chocolate lovers. But we were only allowed to look at the men, which makes it conditional. So again, we're looking for chocolate lovers amongst the men. And again, 21%. Now, there was no table that number came up from. I kind of got that from my own table. And then now this next one actually comes from our table, right? So again, the proportion of teenagers that use Facebook. So again, of teenagers. That's limiting me. That's my condition. I'm only allowed to look at teenagers. So this back part is only looking at teenagers. And of those teenagers, what proportion used Facebook? So again, let's go back to our data so you can see where I got this number from. So the condition was of the teenagers. So I'm only looking at that teenager row. Of those teenagers, 10 of them use Facebook. So 10 out of 280. So again, conditional, my denominator changes because I'm only allowed to look at of the teenagers. So that's the 280 teenagers, and 10 of them use Facebook. 10 divided by 280 is where I got 0.036 or 3.6%. So very small proportion of teenagers use Facebook. Now check this out. Now I'm going to switch it around. How cool is this? The proportion of Facebook users that are teenagers. So notice now the of Facebook users, I'm only looking at the condition is you got to love Facebook. So that goes in the back now. So see how the wording changes the order here. Super important. Now, and this time I'm looking of those Facebook users, what proportion of teenagers? So I'm looking for the proportion of teens amongst the Facebook users. So now I'm looking vertically, right? Now I'm looking of those 174 Facebook users, 10 of them are teenagers. So the denominator changes. So now we're looking at 10 out of 174. Super, super important you understand this. So again, the condition, the of, the amongst, the back part, that changes your denominator in terms of that limits you to who you're allowed to look at. So again, this notation, this symbols, the P, this is just for quick reference, quick understanding of what you're trying to find. All right, now let's really get into the nitty-gritty of truly analyzing two categorical variables. Anytime you're analyzing the relationship between two categorical variables, you are asking, is there an association? This is perhaps the most important question that you could ever answer when you're looking at two categorical variables in a two-way table. Is there an association? So first off, let's make sure we understand what an association means. An association between two categorical variables means, as a group, the outcome of one variable tends to change based on the outcome of a second variable. So again, that's what it means to have an association. One variable has a tendency to impact or change another variable. An association between two variables means that they are dependent. They are dependent on each other. One affects the other. This is not independent. We actually don't use the word dependent very often in statistics. I don't really have a great answer as to why. So we usually say independent or not independent. So not independent means that they are dependent. Not independent means that they are associated. One variable affects the other. So the opposite would be independence. Independence means that one variable does not impact another. So to truly understand this, let's take a look at a couple examples here, and then we'll look at a two-way table for how we could actually figure this out. All right, so here's a really good example that I love using every year to just try to solidify what an association means. So anytime you're examining, hey, is there an association? The first thing you always want to do is start off with a marginal distribution. So if we have two variables, gender and candy, and we want to know, hey, is there a relationship? Is there an association between gender and candy? Okay, here we go. Start off with a marginal distribution, looking only at one thing. So I'm going to look at chocolate, and I'm looking at all the people surveyed. I notice, crunch the numbers, 35% love chocolate. Marginal has nothing to do with gender. Chocolate, 35% like chocolate. Then I examine the conditional proportion of that same outcome across the other variable. So I'm still going to focus on chocolate, right? But I started with the marginal. The marginal was saying, what proportion love chocolate? Now I'm going to look at the conditional. I'm still focusing on chocolate, but I want to look across the other variable of gender. So I'm saying, okay, let's do this. Of the men, what proportion like chocolate? So again, I'm still looking at chocolate, but now I have that condition of only looking at the men. That changes my denominator. and I found out that 21% of the men love chocolate. And then I did the same thing with women, the other variable. I'm still looking at chocolate, but now I'm looking at women. Sorry, I ran out of room. That's a W for women. Getting really messy there. All right, so of the women, still focusing on chocolate, of the women, 48% love chocolate. This tells me there is an association. Why? Because the other variable of gender changed the chance of a person liking chocolate. Regardless of gender, 35% of people love chocolate. But all of a sudden, only looking at the men, it dropped. Of the men, you're less likely to like chocolate, right? 35 is like my baseline. But if you're a man, it goes down. Something about being a man makes you less likely to love chocolate. I don't know why. And if you're a woman, it goes up. If you're a woman, 48% love chocolate. So something about being a woman makes you more likely to like chocolate. So this is clearly showing that gender has an impact on if you like chocolate or not. So I have that baseline to compare to. 35% of all people surveyed love chocolate. But of the men, it goes down. Of the females, it goes up. Clearly, there is an association here. Something about your gender definitely is related. Now, please don't use the word cause. Do not say, hey, I saw that you're a boy. That's going to cause you to like chocolate. No. Just relationship here. But there's definitely an association going on here. All right. Now, with that said, what would it mean if there was no association? Independence. Well, same process. Start off by first analyzing the marginal distribution. All right. Of all people, 35% like chocolate. Don't even mention gender, marginal, just focus on chocolate. 35% like chocolate. But imagine if this happened. Of the men, conditional, of the men, 35% like chocolate. Oh, okay. Of the women, 35% like chocolate. Huh. So it appears it doesn't matter if you're a guy or a girl. There's 35% like chocolate. It did not change. The gender, man, didn't make me more or less likely to like chocolate. If you're a female, it didn't make you more. It was still 35%. Now, a lot of kids ask, does it have to be exactly? Well, no. I'll maybe give you a 1% wiggle room either way. But again, if it's close, super close, that's an example of no association, which means independent. Obviously, gender has nothing to do with you liking chocolate or not. That's an example of no association or independence. So let's try to talk about this generically, because again, a lot of kids tend to kind of mix some things up here. So again, I want to make sure you're very clear. First thing to do, just generically speaking, no solid example here. Look at your variable one. Look at a variable and find the proportion of an outcome for that variable. Again, a single variable. You're only looking at one thing, marginal. Then you want to look at that same outcome across the other variables' outcomes. I know it kind of gets a little confusing, but what I'm trying to show you here is that, if you're going to look at chocolate, continue to look at chocolate. But now you're doing it conditionally, right? Of the men, of the women, of the elderly, of the teenagers, of the elderly, or I said elderly, of the middle-aged, of people with black hair, of people with blonde hair. I mean, I could sit here all day, but, if there's truly independence going on, if 35% of people like chocolate, it shouldn't matter anything else. If you have blonde hair, 35% like chocolate. Of elderly people, 35% like chocolate. Of rich people, 35% like chocolate. Of Democrats, 35% love chocolate, right? The moment you add another variable in and all of a sudden the proportion of you liking chocolate changes, that's when we start to see an association. All right, so let's finalize this by looking at an exact answer, exact problem that we did from our class, right? So here we go. So here is our data, and our question is very simple. Is there an association between age category and social media? Now, I tell kids all the time, there's lots going on here. You don't need all of these numbers. You do not need all these numbers. You only need a couple. So the first thing we have to decide is, what am I going to look at? And you got to first say, listen, being a lover of Facebook doesn't impact my gender or doesn't impact my age. It doesn't work like that. It's my age that clearly might make me lean one way or the other. So we want age is what's going to be kind of the condition here, because the age could definitely change if I use Facebook or TikTok. So I'm going to focus on the proportion of people. And again, you just got to pick one, right? Let's focus on the proportion of people that use TikTok. Okay? And again, I'm only looking at one thing and one thing only, TikTok. And that's 168 total people out of 875. Grab a calculator if you need to. 168, I'm using my calculator right now, out of 875 is 19.2%, 0.192, or 19.2%. Then, that's the marginal, right? Then what I want to do is I want to start looking at, again, I'm still looking at TikTok. Do not change what you put first. But I want to see, does being a teenager change that? So now all of a sudden, I'm only looking at the teenagers, changing my denominator. 280 teenagers, 117 love TikTok, 117 divided by 280, 0.418, or 41.8%. Now, I don't think I really need to keep going. Pretty obvious. If you're a teenager, it certainly made you much more likely to use TikTok. And again, you don't have to do all of them, but do a couple to really hit your point home. So maybe I'm going to do elderly next. So once again, still looking at TikTok. You cannot change what goes first. You're just changing the condition. So let's see. Of the elderly, 115 elderly. Looks like 5 of them use TikTok. 5 out of 115 is 0.043. So 4.3%. Okay, so pretty obvious here, right? Of all people, 19.2% use TikTok. But of the teenagers, skyrockets up to 41.8%. If you're elderly, it goes down to 4.3%. Clearly, there is an association. Age category definitely impacts your social media. Do I have to check out the others? Honestly, no. I have proven my point that there is definitely an association going on here. You can continue on and look. Facebook is going to be more used by the elderly, less by teenagers. But again, you don't have to go through all the data to answer the question. Once you kind of get a beat that something is going to answer your question, run with it. Now, I want to mention that a great way to visualize this is with those segmented bar graphs. Remember, we talked about these in the last video. This makes you visually see it, right? Segmented bar graphs show the proportions within each age. So this is conditional, right? Every number in this teenager bar is conditional. It's conditioned that you're a teenager. Same thing for the others. So if we think about the TikTok is the green, you could clearly see, right? Now, you don't know the exact numbers. We already did that in the previous slide. But you clearly see of the teenagers, a much larger proportion use TikTok than of the middle-aged or of the elderly. And then you can even focus on Facebook. Of teenagers, very few use Facebook. Of the elderly and middle-aged, a lot use Facebook. So you clearly see that age category definitely plays a part in terms of what social media app you prefer. So the only thing left to do is make sure that you know how to write up this answer, because I cannot tell you how many kids get a very bad grade when they are asked, is there an association? It's because they don't answer it nicely. So I follow 4 steps. Step number 1, answer the question, right? After you do all the math work like I just did, right? All it takes is a little bit of math work like I have here in red. Answer the question. Yes, there is an association between X and Y. You know, context, right? Who, what, where, when, why. Then you got to back it up with proof. Start off with that marginal distribution, that marginal proportion for an outcome. That's your baseline. 35% of people love chocolate. Then go ahead and give me the conditional proportions, proving that they either change or don't change if it's independence. So again, now you're going to say, okay, of the men, this proportion like chocolate. Of the females, okay? Or again, for social media, of the elderly, this use TikTok. Of the teenagers, this proportion uses TikTok. Then you actually want to reiterate your conclusion a second time at the end. A nice, solid paragraph. So here would be my full credit, 100% right answer if you were asked about association between age and social media. So first, answer the question. Yes, my data certainly reveals an association between age category a person falls in and social media apps they prefer. Who, what, where, when, why. A lot going on there. Very well written sentence. Now I'm going to go into why. Well, for example, let's start off with that marginal distribution, 19% of all people use TikTok as their top social media app. However, here comes the conditional. Of the teenagers, it skyrockets up to 41.8% use TikTok. Of the middle-aged adults, only 1.7% use TikTok. And of the elderly, only 4.3% use TikTok. An association, now here comes the fourth part, reiterating my answer. An association clearly exists. Teenagers have a tendency to use TikTok at a much higher rate than elderly or middle-aged, showing the relationship. Nice final way to kind of conclude it. Did I talk about Facebook, Twitter, Snapchat? No. I talked about what I needed to talk about to answer the question. All right. Now, I want to end with this real quick. What would no association or independence look like? Again, you would see the same numbers across the board. So once again, let's choose Instagram this time just to do something different. So we'd say, okay, what proportion use Insta? Once again, this will start with the marginal. I'd say 200 out of 875. 200 out of 875 is 0.229, 22.9%. That's your baseline. About 23% of people use Instagram. Then I'm going to say, okay, I'm still looking at Instagram, but I want to say, does being a teenager change that? Okay, well, so now I'm looking at the 280 teenagers. Condition, change the denominator, right? And of those, 64 used Instagram, 64 out of 280. Wow, 22.9%. So it appears if you're a teenager, doesn't make the chance of you using Instagram go up or down. And then again, let's look at young adult. So again, we're still looking at Insta. Can't change that first guy. Now we're going to look of those that are young adult, YA for young adult. Once again, the condition young adult, 304, it's going to change my denominator. Of those young adults, 69 use Instagram. 69 divided by 304. Oh my gosh, wow. It's about 22.7%. Not exactly the same, but pretty darn close. So this is showing me that, apparently age doesn't change me using Instagram. Now again, all of these numbers are different than the previous table. I had to alter the numbers so that there would be no association, right? I can't. There can't be both at the same time. So this is a slightly different chart. And then here's something else that's really cool. A segmented bar graph. Look at this. What do you notice? It's all the same. Look at Facebook, Instagram, Snapchat, TikTok, Twitter. Teenagers, all about the same. Doesn't matter. Doesn't matter. Look at the red, young adult. All about the same across the board. Oh, look at the middle-aged adult. All about the same across the board. Again, that's no association. You're kind of seeing the same thing happen across the board. Now, I'm not saying, so please listen here, the 22.9% is for Instagram. I'm not saying that that's the same for Snapchat, TikTok, Twitter, Facebook. That's not the same. It's across the age category. So I'm seeing about 23% of all people use Instagram, of elderly, 23%, of middle-aged, 23%, of young adult, 23%, of teenagers, 23%. Wow. Age doesn't change the chance of me using Instagram. That is no association. They're not connected. They're independent of each other. All right, guys, I know it's a little bit of a longer video here, but lots of super important stuff to go into analyzing categorical data. Not very difficult, but boy, you got to know it all.